Hi guys, and welcome to video number 177. This video is on trigonometry, but this time we're finding angles in right angled triangles. Keywords are the same things as in the last video, with the exception of the word inverse. Now an inverse is when you undo something, what we're referring to here is we're undoing the multiplied by the trig ratio bit, and the only way we can do that, we can't divide by a trig ratio, it wouldn't make mathematical sense. So the only way we can do it and get around it is by inversing it. There's a button on your calculator you press to get the inverse function, the inverse trig ratio up, and that is shift and then whatever the sine, the cos or the tan is that you need in the particular problem. Depends on the problem that you're doing. So I'm going to go through the method and then I'll go through some questions with you. As always, to find a missing angle in a right angled triangle, you've got to label the sides. Same as last type of questions. When you're finding the sides, you label the sides: hypotenuse, opposite and adjacent, H, O and A. Write out SOHCAHTOA and choose which trig ratio to use based on what two sides you have got. Alright, so it's slightly different, that little bit. Alright, you're going to get two sides in it and you're going to be able to find an angle. You could also find the missing side length using Pythagoras, but that's not what we're after in this particular problems. Draw a formula triangle, cover over the bit you want, same as last time. Write a formula out, same as last time. Substitute, calculate, same as last time. Slightly different. Very end bit. When we're finding an angle, we always inverse to find the angle. You'll see what I mean when I do the problem. And you can use trigonometry in rats if you have two sides. You've also got to remember that S stands for sine of the angle, C stands for cos of the angle, and T stands for tan of the angle, just like it did in the last video. And it always will do. So, question number 1. Find the value of the missing angle. Give your answer to one decimal place. Start off by doing the labeling. So the labeling, it's based around the two sides that we've got and where the angle is that we want to find. So this angle we want to find down here in the bottom corner. There's our right angle. Okay, so that's our hypotenuse, right? That's irrelevant in this problem because there's nothing on it, right? So this is the opposite because it's opposite the angle we want, and this is the adjacent because it's next to the angle that we want. Okay, so we're going to write out SOHCAHTOA just like we did in the last video. Okay, you don't have to do this every single time if you're starting to get good at it, but it's useful to remember what you need to use. So O and A is the two side lengths that we have. So we're not going to use this or this, we're going to use this one because that's got O and A in it. Write out your TOA triangle, T-O-A, okay? And then that's a little multiplication symbol in there, by the way, if you can't see what that actually is. And then you're going to cover over the thing you want. So T is the thing you want. Remember, T stands for tan of the angle. All right, so tan of X is equal to O over A, 16 over 22. All right, now this is not the final bit. The final bit is to get rid of the tan that is next to this angle. So X equals tan to the minus 1. Like I said, you've got to inverse it. Brings up a bracket on the calculator, 16 over 22 goes in. That's the number that's on this side, right? And this is the only point you need to bring the calculator in for, okay? So you press shift, tan, right? Then you get tan to the minus 1. Opens up the bracket, you press the 16 and the 22 after pressing the fraction button, and then you close that. That's exactly what I've written down. That'll give me my answer to one decimal place, 36.0. Okay, so X equals 36 degrees. Okay, I'll show you again with a slightly different example. So this B question, we've got some decimals, doesn't make a difference. We've got to label the triangles, so that's our opposite because it's opposite the angle we want. This one's the hypotenuse and that one's the adjacent. Okay, this is because the right angle is there in that problem. SOH, CAH, TOA. Okay, so opposite and hypotenuse, it's SOH that we're interested in, not that one, not that one. Draw the triangle. I'll draw it a bit bigger if I can. SOH. Okay, so that line means divide. There's a little time symbol in there. Sine of the angle equals opposite over hypotenuse. So SIN of the angle equals 43.5 over 67.7. Inverse it, sine to the minus 1 of whatever that answer is, so 43.5 for 67.7, right? Bring the calculator in, do the calculation. Shift, sine. Move that out of the way so we can see what we need to actually type in. Fraction button, we go, just check all that's all good, and then press equals. So 39.98, again to one decimal place, going to round that up to 40. So x equals 40.0, don't need to put the 0.0, 40 degrees. Okay, hope that makes sense. Fundamental skills of trigonometry, finding angles. Okay, now question number 2, we've got a rhombus, and we've got to find angle bad. Now rhombus is a pushed over square, all right, so all of these side lengths are the same, all right. It's not necessarily that relevant for this, but what we should know about a rhombus as well is the diagonals bisect one another at right angles at 90 degrees. Okay, and that's very, very useful in this particular problem because we know that we can get a right angled triangle. Now bisect means cut in half. Okay, if we're cutting in half here and cutting in half here, we've cut this length in half as well. All right, so what I'm going to do is I'm going to draw a triangle, a right angled triangle from the problem with the dimensions. I'm going to call this middle point here point M. Okay, I'm going to join A to M together on my triangle here, and then M to B, and then B goes to A. Now B to A is 18 centimeters. All right, we have a side length there. What we're going to be looking for, because we want the angle, is we want this angle here. Let's call it X. So we're going to call it X in this drawn out problem I've got on the side here. So it's a good idea to do this. And then A to M is 15 centimeters, it's halfway. We've got the two side lengths, we can work out that angle. Remember, we want to find angle bad, all right? So we need to double our answer at the end because this is going to be half of the whole answer, all right? Because it's bisected that angle. AC is an angle bisector of BAD, all right? So we just double our answer at the end. All right, so basically it's a case of labeling the triangle again. So that's the opposite, that's the adjacent, that's the hypotenuse. Okay, CAH is the one we're going to use here. All right, because it's got the adjacent and hypotenuse in it. So cos of the angle equals adjacent, which is 15, over the hypotenuse, which is 18. Okay, x equals cos to the minus 1, 15 over 18. That we can type in. We can get that answer. So let's bring that over a little bit. Cos, shift, cos. That gives us our inverse cos, and then 15 over 18 in the fraction. Don't have to worry about simplifying those fractions. Calculator does it all for you. So x equals 33 point something. 33.557, I think it was, something like that, or 577. 557, there you go. So there's that angle. That's, remember, is half of what we want. So let's say the angle bad equals double that. So just times it by 2. And we get our answer, 67.11. I'm just going to round it to one decimal place, so 67.1 degrees. Okay? So that requires just a little bit more knowledge about some other things in maths. All right? That's a more difficult type of trigonometry problem to find an angle. Right, so have a look at the third and final question. Now this one is a drone. A drone flies 4 miles due west from point A and then flies 7 miles due north to point B. What is the bearing of B from A? All right, so we've introduced a bit of bearings. There's a video on bearings if you want to understand it a bit better. All right, compass directions are north, east, south and west. Never eat shredded wheat. All right, that is not me saying don't eat that particular breakfast cereal. Please do. It's probably good for you. It might not be good for you, but it's high in fibre. And if you need a fibre in your diet, eat some shredded wheat if you want to. I don't care. Anyway, that's just me knowing the compass directions. Never eat shredded wheat. So we're gonna draw a little diagram here of where this drone goes. So here's point A. All right, let's label that as point A. The drone goes 4 miles west. Okay, so that's to the left. And let's just label that as 4 miles. And then it goes 7 miles to the north. All right, and then it gets to point B. All right, what we want to do is work out what the bearing is. All right, which is the measure of a turn. All right, the angle of B from A. So we're going from A, so we draw a north line from A. We want to know how to get there. That's the angle that we want to find. Okay, and what we've actually drawn here is a right angled triangle. All right. By joining B and A together. There you go, there's our right angled triangle, there's our right angle there. And what we know is, for certain, that here A to this point here, this bottom line that I've drawn here, that's definitely 270 degrees. So what we need to work out is this angle here, the rest of it. Okay, I know that's 270 because it's 3/4 of the way round. All right, it's exactly 3/4, isn't it? All right, so I just work out that last little bit, and we've got the bearing of B from A. Okay, and we can do that because we've got some lengths here, and we can use trigonometry to do it. So that's our opposite, that's our adjacent. All right, TOA is the one we're interested in, TOA, because it's got opposite and adjacent in it. So tan of the angle, let's call it X, okay, equals opposite over adjacent, so 7/4. And then we have to undo the tan bit of it by inversing it, so tan to the -1, 7/4, and then X equals, so let's bring our calculator in, do that, shift tan 7/4, found out that that bit's 60 degrees, 60.25 degrees, and then, and this dot 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 just means there's some more decimals there, and then all we have to do is add that onto 270. Okay, so answer plus 270 degrees equals, and I'm adding 270 on because that's 3/4 of the way round. Bearing's always measured in a clockwise direction from the north line, from the question, from the point where the question says from, and give your answer in 3 digits. So 330.25. Let's just say it's 330.3 degrees, right? So 330.3 degrees will be our answer. Well, 3 digits. Let's just knock that 0.3 off the end. All right, because that's a bearing. All right, 330 degrees. And that'll do. That's it. What's the bearing of B from A? Done it. Okay, gone from A all the way round to B, had to work out that missing bit of angle there, add it onto the 270 to 3/4 of the way round. Okay, and that's, yeah, a really tricky last problem for, you know, if you find that on a foundation paper, good luck to you. I think that'd be very, very tricky to do. But hopefully you understand how to use Pythagoras and trigonometry now. Sometimes they combine both of those things in a lovely one question. I haven't got any examples of that I've shown you, but if you've learnt both of the things, you'll be able to combine it yourself. All right, just got to figure out that you need to use both things. So thanks for watching once again. Stick around for some more tough stuff. The rest of the stuff will be, there's a little bit more foundation stuff, but most of it is higher. All right, so take care of yourselves, look after one another. Thank you very much. See you again. Bye bye.